Good morning, class. Today we're going to go over equations and how to solve them. When you solve an equation, the idea is to get your variable, that unknown letter, all by itself. So in this case, since I'm using the letter x needs to be alone. We want to have x equals and an answer. As we're doing this, what we're going to be using is opposite operations, or inverse operations, whichever word you prefer. So as we go through, we're going to look and we're going to find x. So let's start on this side of the page where we have this addition problem. If I have my variable and it's being added to a number, in order to get x alone, I need to do the opposite thing. So the opposite of add would be subtract. And I show that subtraction underneath. I am showing the operation I'm using. And then when I'm going to give an answer, I rewrite it under my line. X equals, now see how I brought the x straight down? 3 minus 3 is 0, so I don't have to write it. And then I just solve this side straight up and down. 10 minus 3 is 7. Okay, so that works out wonderfully for us. Let's look at a problem with subtraction, because as you can see, addition and subtraction are opposites. If I have x minus 4 equals 5, the opposite should be to add 4. And when I say to both sides, I mean to think of the equal sign, and we have a side over here, and we have a side over here. So again, bring the x straight down. A negative 4 plus 4 is 0, so I don't write it. And I bring down 5 plus 4 is 9. So you can see I'm using my rules and I'm working straight up and down. All right, let's start looking at some what-if situations, because while the basics are pretty simple, we're doing the opposite to get x alone, sometimes we can get a little confused when weird situations happen. For example, there is some confusion with these two problems, and they are slightly different. In both of them, there's a number, and then x comes second. However, the difference is in this equation, the x is a positive x, and in this situation, the x is negative. When the x is negative, we know we don't want a negative x. It needs to be positive. So we do a thing where we add it to both sides. Because what that does, while it doesn't solve the problem, because I still have 10 plus x over here, now it's positive. If I keep bringing this down, a negative x and a positive x are opposites, so it's gone, and I have 8 left over. Now the x is on the opposite side, so we do want to be taking care of this number over here, not this number, because our goal is to get x alone, and taking out this number is not going to help that goal. So let's look over here, and minus 10 on this side, and minus 10 on this side. This is another place where we tend to have a little bit of confusion because we have a subtraction sign. However, you and I both know that the subtraction sign is the same thing as a negative. So, as I'm dealing with this, I need to think I have an 8, which is positive, and a 10, which is negative, and I need to do different signs, subtract, and get 2. Now, should my 2 be positive or negative? Oh, negative, of course. So, as you're doing these problems and you're working through, remember that every single subtraction sign you see, you need to think of it like a negative and use the rules that we've been studying. Okay, so let's move on down here. In this situation, sometimes we see the plus sign right here and a negative sign right here. So there's some confusion. Which one are we doing the opposite of? Well, to get x alone, I need whatever I do to cancel out a negative 3. So the opposite that we're looking for is, instead of negative 3, we want a positive 3. Those are opposites. Subtracting 3 again would not help. That would actually give us a negative 6. We don't want to do that. We want a negative and a positive so that they can cancel out and be 0. And since x is already positive, I can just bring it down, make sure to do the same thing to both sides, and get 13. Voila! All right, this last one right here can be a little bit tricky because we have a combination of a negative number in front and a negative x. And this is why equations can get confusing sometimes, is there is a lot of different combinations, and no matter how many notes we take, we're never going to get them all. So we need to remember rules and apply those rules to different types of situations. So in this case, because I know I don't want my x to be negative, I'm going to take care of that first by doing the opposite. And when I bring this down, I need to remember this negative is stuck to the 5. And now x is over here. So I need to look at this, and I need to get rid of that 7 by subtracting. X is alone. But look, we have subtraction. Again, the temptation is just to minus and say the answer is 2 and I'm done. But those subtraction signs are negative signs. And if I have both of them being negative, I need to use the rules, same signs add, and keep it negative. So be very careful. All right, here are 2 problems for you to try on your own. First problem, second problem. Use the examples of what we just talked about and solve. Go. Okay, let's check and see how you did. On the first problem, the x was on the opposite side, so we're going to deal with this side first. I noticed that my x was negative, and I didn't want to deal with a negative x. So I added it to both sides, and I got x minus 4 equals 10. Then I had to do the opposite of minus 4, which was add 4, and I got x equals 14. The second one was pretty basic. Opposite of add was subtract. So I subtracted 3 on both sides and got 2. How did you do? Hopefully good, because we're going to move on to the other side and deal with some multiplication and division problems. Okay? Let's start with a basic one. We have 3x equals 15. Now I want us to remember that when they're smushed together like this, what this means is 3 times x. We just don't write the multiplication symbol because it can get confusing with the x. We could use a dot, but we usually just smush them together. Okay, so knowing that this is multiplication, we would need to do the opposite in order to get x alone. So the opposite of multiplying is dividing. And I'm showing the division with a line right here. That's a fraction bar is a division sign. 3 divided by 3 is the magic disappearing 1. I have 1x. 15 divided by 3 is 5. There, I've solved it. The tricky part and the what if happens right here. Again, I have a number and it's being smushed up with the x, which means multiplication. However, this time the number is negative. And so while I know I need to divide, sometimes people get confused and they divide by the 2, but we forget the negative. The reason we keep the negative and don't do the opposite and make it positive is because we've already done the opposite. We are using the opposite of multiplication. We're not doing the opposite of subtract is add. We are doing the opposite of multiply is divide. And because that's the opposite we're doing, we cannot ignore that negative that's been there the whole time. It needs to still be there. Okay, so be very careful. When we're over here and we're doing opposite of minus is add, that's great. That's the opposite operation. But over here, the opposite of multiply is divide. We're not changing the negative at all. Okay, sorry to slow you down. There's our magic disappearing 1, because a negative divided by a negative gives us a positive. Yes, our x is positive. And over here, 36 divided by a negative 2. Well, let's divide first. 36 divided by 2 is 18. And a positive divided by a negative should be a negative 18. Okay, we're doing great. Let's talk about the same thing when we have a division problem. Here's our basic example. If I have x divided by 3, I know the opposite of dividing is multiplying. And so we show it off to the side with the parentheses as multiply by 3. Because if I have a 3 being multiplied and a 3 being divided, that's again our magic disappearing 1, just like we had here, a 3 being multiplied and a 3 being divided. Oh, that works. Those are opposites. So my x is alone. On this side, I need to remember that because we are multiplying, I need to multiply on this side. 7 times 3 is 21. Ta-da! But there are negatives to consider. So in our second example, I do have a negative 4. Just like we talked about earlier, the opposite is not adding 4, because that's not what's happening. Division is what's happening. This just happens to be negative. So we are going to multiply by negative 4. Those are stuck together. And on the other side, multiply by negative 4. These cancel. Bring down the x. And 6 times 4 is 24. And a negative times a negative is a positive. Okay, one last thing to talk about now that we've gone over one step at a time. And that's when I have multiple things happening to the x value. In these situations, we have an x that is involved in 2 different operations, which means we need to use our order of operations rules in reverse to tell us what to do first. Try these 2 problems and we'll check your answers. Go. Okay, here's me showing my work. Pink for the first step, blue for the second. I got 16 and 6. How did you do?